aquifer, the biggest changes have occurred in this northern area, no? Central and northern area. Anyway, it's just an example on how you can actually automatically extract the topography along a profile and the kind of application that you can use a profile for. I think in terms of also groundwater is quite interesting to have this kind of representation because it gives you really the idea of the water flowing. Good. So now that we have done this, was a bit quicker, but just for you to have a look and know now that you can do that, I would suggest that we actually do this third part, which might be more of interest for you, because
So the preparing is finished.
yeah. Would you like to maybe some question? I mean, a moment to ask.
What you did and explain, or there was some more information.
Mm.
So because of shortage of time, you mean we will stop here? Because as you have analyzed the cover groundwaters, the profile and the information beneath profile, how can my colleagues add those things to the profile? So they will need some more information.
Absolutely. And that will be available.
Draw the layers and how to draw, add the colors. And for example, if you find information regarding the deep geology,
Yeah.
so how to add that there and how to, as you did, that was very nice.
Yeah. Well, I did it. It's not very nice. It's like a very preliminary thing that I did in Excel. But what I generally do then, once I have my ideas, or even you can just even better is actually to print out your profile and do it by hand. Because by
This make it new for our colleagues.
Yeah.
It's very good. Other, previously, we worked by pen or by hand. And drawing the sections.
Yes.
And the another difficulty, draw the transition, we have yes with the profile. If there's some profile and it's a graded and map to be polarizing.
But I tell you, if you are capable of doing it by hand, you are capable of doing it on the computer.
And some colleagues of they will put it profile start a software, you will see some water and sulfur. They will draw.
Great. There's many ways of doing it.
But this is easy and better.
Okay.
The concept.
Yeah, please go ahead because of
Shortage of time. Yes. Okay. So last part that I will show you this morning is how to, let's say, once you have done this interpolation of yours, here I will show you the case of Farah because it's maybe the one that is the most impressive. Once you have done all these different manipulation that you have done previously, so just as a reminder, let us go to Farah. So you have actually created these contour lines based on these real measurements and used as a reference for the altitude. You have used the SRTM. So you have done this and creating these contour lines goes through the creation of these interpolation, and the interpolation that we have used is the cubic spline, but as already said, it can be any other kind of interpolation. Now, when you are interpolating and creating the piezometric contour, this interpolation is based on the hydraulic heads. So these are altitude of the water table. Now let me show you how it changes in Farah. So these are very impressive. So those are the piezometric lines, the piezometric contour in Farah at the beginning of the measurement. So that was the first measurement that was done in Farah on those monitoring wells in 2021, maybe. Farah is like 4 or 5 years, 4 years maybe of monitoring. So those, the contour lines you can see go from the top here is northeastern and flow towards the southwest. Now the contour lines in end of 2024, look how they go contrary. Now they are flowing from the south to the northeast. And possibly is because you see the drawdown in Farah has been excessively strong. So when you have these two interpolation, you have interpolation of your first and last measurement. Probably what you want to understand is grasp the feeling through the piezometric heads, piezometric contours. But what you also want to see is more concretely where the changes has become the most important and where there are least. So what you can say is, what you can do is simply making a difference between your first and your last measurement. So as in this case in Farah, we see that everything is depleting. Make in the first measurement, your hydraulic heads are here, high here. So the second measurement or last measurement, the drawdown brought them here. If you do first measurement minus last measurement, you will have the difference between these two, and you can represent this difference. So actually it's very simple. In QGIS, you have this tool, raster calculator. And here you will just have to write the expression, which is your cubic spline first measurement minus your cubic spline last measurement. And now here you just have to give it a name. So we said that it's Farah cubic spline difference. What you get is this difference. Now, to make it nice, let's use again this polygon that we have created previously, so that it will cut all outside, all the information outside that we can't say, it will cut it off. So to do that, raster extraction by mask. So you have your raster that you created, which is the difference. And let us search for our this polygon and create the mask. Okay, now you have it here. It's with your master. Let's give it a color. So now you can see actually where the difference are the most occurring. So the red colors will give you these very, very high difference. What is occurring, this high difference, and then the low difference. Maybe it's working. Now you can also see what it corresponds with. So this low difference actually corresponds well with less population and less agriculture. So probably Farah Para seems to be a lot under pressure by the agriculture that is pumping water from groundwater. So, and apparently here the difference are a little bit less, maybe because less population, less agriculture, close to the mountains, maybe some kind of storage is happening. Now, the last thing that I'm gonna show you is how will you from here estimate what is the amount of depletion that this corresponds to.
The total volume of water over extracted.
Exactly. Over extracted. Exactly. So I think here I'd rather even do it maybe on some kind of paper. But anyways.
The paper is here.
Yeah.
No.
Yeah.
You. Do you need this paper?
Yeah, I don't know if this make you think it a bit. So here we have something that is yeah, maybe I need it maybe not. Maybe in the afternoon. So here we have something that